In today's video, we're going to look at all of the possible rules that we could use to prove that triangles are congruent. So again, if you'd like, go back to the demonstration that I showed you the first couple pages of in our last lesson, in the 5B lesson, and you actually can find a page on each one of these rules. So we usually abbreviate these with the letters S, A, or we have one in there, HL. The things that abbreviates with, well, what are the things that we have in a triangle? So anything that we see as an S, that's really talking about one of the sides. Anything that we see as an A, well, that's one of the angles. When we have H and L, those are particular to those types of triangles. So let's hold off on that for one quick moment. So our abbreviations are really just saying, here's our shortcut with what pieces of information do we need to know to prove our triangle's congruent. So in the last video, we looked at the SSS postulate or rule, and that just means we have three sides congruent. So three sides congruent. And so let's mark our two triangles, and we have a little bit easier to see, short side, long side, and kind of our medium side in the middle. So we would see these in a diagram marked with all of our sides congruent, aka using your dash marks. And so these triangles are definitely twisted around on each other, but we would be looking for all three sides to be marked equal to all three sides in another triangle. SAS stands for side, angle, side. And it's exactly in the order that the abbreviation gives you. So we have the abbreviation SAS with the A in the middle. So this means that we're going to have the angle included between two sides. So one version of this might look like we have two sides congruent. So let's use the left side and the bottom side, or the right side and the top side. And then we're looking for the angle in the middle. In other words, the angle that touches both of those sides. So that would be this guy in the bottom triangle and this guy in the top triangle. ASA reverses the order. So ASA has two angles and a side, but where's the side compared to the two angles? Oh, well, it's in the middle of the two sides. So we're going to say side included between two angles. So again, let's mark possible information with how you might see these triangles organized. So we need two angles and a side that is in between. In other words, it touches both of those angles. So let's use our top small angle and our bottom looks like an obtuse angle. And then we're going to use that guy on the left. Well, that's the shorter side. So shorter side, smaller angle, bigger angle. So we would have to have that side touching both of those angles. Now think about AAS. Where did the side move in the abbreviation? Well, the side's now, it's off on the end of the name. So it's not actually in the name touching both sides. So it's the same sort of thing in the triangle. We're going to have a side that's not included. In other words, it only touches one of the angle or angles. Only touches one angle. And it has to touch the same angle for the triangles to be in the same order. So let's say we had our short side again. We're going to use the smaller angle. So I can't use that obtuse angle and still show angle, side. I need to use this extra one off on the end. So check out these diagrams. Again, we have two angles, but the side only touches one of them. Alrighty, so HL special, or this is a little different because it has HL instead of A and S. Well, the HL actually stand for specific sides in a right triangle. And so you'll notice the diagram's a little different on this one. We have what looks like a right angle, so I'm going to go ahead and mark that in. The H and L stand for hypotenuse and leg. So specifically, in a right triangle. So we have to have a right triangle to be able to use this rule, and we have to have the hypotenuse and one leg as congruent. So hypotenuse, well, that's our middle piece that's directly opposite from that right angle. And again, if you have difficulty seeing it, look at that right angle. It's kind of like an arrow that points towards your hypotenuse. And then we have to have one of our legs, in other words, one of the shorter sides. And so let's use the top one and that bottom one. Alrighty, so along with this, so not only do we have to be careful of following kind of the pattern, following the order of which pieces are congruent, we can also start using kind of some overlapping pieces. So you'll notice that all of the triangles I showed you so far, they don't touch each other, but we could have triangles that kind of work together in a diagram, and we've seen some of these things before. So using the idea that we could have shared sides that are actually going to be the same side in a triangle, or we can use information that we looked at before in either Unit 2 with vertical angles or Unit 3 with parallel line angle pairs. We can actually do a lot more with some of these diagrams. So let's look at our first example. So in our first example, we're given that AB is congruent to CD. So let's mark that. So AB is congruent to CD. They also gave us that angle B and angle D both equal 90 degrees, and they do. They look like right angles, and they gave us that info, so let's mark it down. So this isn't a whole lot different than when we were talking about proofs before. We're not going to do proofs today. We're just looking at the rules right now. Okay, so here's what we can assume about this diagram. Both of these triangles have AC or CA. So both of these have this shared side in the middle. So that side is actually part of both triangles. It's part of the triangle down on the bottom, and it's part of the triangle on the top. So I'm going to go ahead and mark that technically as congruent. And so we can assume that any shared sides are congruent. And we're actually going to have a rule that we use when we do proofs that we'll start talking about next video. Alrighty, so our congruent statement, let's name our congruent triangles. I'm going to go ahead and draw my orders just so I can kind of keep things in order, make sure I'm naming things in the right way. So I'm going to name my first triangle A, B, C. So look at where I went according to the different marks that I have. Use those as kind of your landmarks. I started at side A, went along the single mark angle or single mark side, went towards the right angle, and then towards my third side. So if I'm going to start in that same way, again, I need to go along the single marked side towards the right angle and then out to my third. So my congruent statement is going to be triangle ABC is congruent to triangle CDA. And so the last piece on here, this is, well, which of the rules that could we use? Well, what kind of triangle do we have? Both of our triangles are right triangles. So as soon as I see that, I consider my HL rule. Do I have a hypotenuse marked? Well, sure. We have side AC or side CA, depending on which perspective we're taking. Do we have a leg marked? Yes, we have side AB and CD marked as congruent, and we have the right angle that we need for hypotenuse leg. So our congruence rule, we could use HL on this one. Alrighty, let's look at example 2. So in example 2, we have parallel lines as marked, and we don't have anything else marked on here. Well, could we use a shared side like we did before? Well, sure. So let's go ahead and mark that as congruent. But that's not enough information. We need a lot more to make this work. So let's see here. We have parallel lines. Well, we did a whole lot with parallel line angle pairs. And when we're looking at diagrams like this, chances are we're probably going to have to stay inside the parallel lines. And wait a second, if we were inside the parallel lines, we only had two versions. We had either alternate interior angles, or we had same side or consecutive interior angles. Which one of those were actually congruent to each other? Alternate interior angles. So I can actually do this with two of them. So I could do this with that top angle near E and the bottom angle near G. And I can flip it around with my other pair of parallel lines. So I could do, I'm going to use a star on these. Same thing, alternate interior angles. Now, notice I didn't pick angles F or H because they don't have a single transversal that touches both of those angles. We'd have to do a combination of too many different lines. So we could say that angle HEG is congruent to angle FGE. We also have angle FEG is congruent to angle HGE. And these guys are alternate interior. So alternate interior angles. So our triangles are absolutely congruent. And again, when we name them, we want to make sure that we're keeping the correct order. So I like to draw an arrow through it. So if I start on the bottom triangle, I'm going to start at the star, go towards the double marked parallel line and towards the double angle. So go in the same way, use your landmarks in your triangles. Starting at the star, towards the double marked parallel line, finishing up at the double angle. So that means one of the ways I could write my congruent statement would be triangle EHG is congruent to triangle GFE. Now let's think about our information. In each triangle, we have two angles and a side marked, but where is the side? The side is stuck in between the two angles. And again, if you're having difficulty seeing this, use the same kind of trick that we used before. So what we did before is we actually covered up part of that section. So let's try that. So I'm going to go ahead and cover up. Let's see, first triangle I named was EHG, so let's try to cover up EHG. So let's see here. Now this is a little harder to do with this weird shaping, but let me at least cover up that middle piece. And so that's not going to work as well. Let's try a different shape. Okay, so let's try this. So we have, that'll work. Or not. Our fill, let's go red fill. Try this with your hand. Apparently my program is not helping me out too much with this. So try with your hand, just kind of covering up that section. If you cover up that top triangle, look for what pieces you have marked. If you look at one triangle at a time, it's a lot easier to see which pieces of info are going to be important. So in this case, we've got, two angles and our shared side in the middle. So that means our congruence rule is going to be angle, side, angle. Alrighty, then our last one, example 3. So in example 3, we know that angle J is congruent to angle N. They told us, so we can mark it. Side KL is congruent to side NL, so we can mark it. This kind of diagram looks familiar, doesn't it? So it's kind of one of these bow tie diagrams that we looked at before. Is there anything in the middle that we might be able to use? Kind of like a bow tie, there's almost, think of that knot in the middle. We have our two vertical angles that we could mark in the middle, but again, they're not congruent to the previous one, so I want to use a different marking. So I'm going to use a double arc. So in this one, we could use vertical angles. And let's see, we could name angle KLJ and angle NLM. So again, why do you think I named them in that order? What do you think I was doing mentally when I was naming them? Think about the order in your triangle. Go past your landmarks. So if I started with KLJ, I'm going in this order. So I have to go in the same order when I'm naming my triangle or naming my angles. Start at that unmarked angle, towards the center, and then out. So my congruent statement could actually be the same order as what I used for my vertical angles. Triangle KLJ is congruent to triangle NLM. Which rule do you think we have with the information that we have marked? And again, if you're having difficulty seeing it, actually take your hand and cover up one of the triangles so you're only looking at one at a time. We actually have the rule angle, angle, side on this one. So again, these take a little bit of getting used to. We want to make sure that we're looking at plenty of these diagrams. So I have a few more examples to look at, but now might be a good time to pause the video, let this sink in for a moment, and then start them back up. Okay, let's look at a few more examples. So again, with these, we're going to mark all of the information that we're given and then try to figure out which congruent statement or which rule we could use. So example 4, we're told that RT bisects angle SRU. Wait a second, what does bisect mean? Means cut in half. So if angle SRU is getting cut in half, that means I have congruent angles down at the bottom. They also told me that RS, segment RS, is congruent to segment RU. Okay, do we have any shared information? We have our shared side in the middle. And so then now we're ready to write our congruent statement and what rule we're using. So our first one says it's giving us the order of our triangle STR. So what order should I name the other one in? Go the same order. So that's going to be triangle, not a whole lot of room, so let me write an arrow. That's going to be triangle UTR. And what rule should we use? Again, cover up one of the triangles. We should be using SAS on this one. Okay, example 5, it's one of those bow tie diagrams. So before I do anything else, I'm going to go ahead and mark my congruent angles in the middle. Okay, let's go through our givens. So angle M is congruent to Q. So again, use a different number of arcs. N is the midpoint of segment MQ. So I'm actually going to draw along MQ just so I know which one I'm using. If that's a midpoint, where's a midpoint compared to the endpoints of a segment? Right smack in the middle. So that means what has to be true about our two pieces? They have to be congruent. So again, I'm going to change my color so it pops it a little better. We have two small congruent segments. So then again, they gave us our first triangle, LNM. So follow it along. We want to be symmetric. We want to go through the same landmarks. So start at your empty angle, going towards the double. So that means our new triangle is going to be, or congruent triangle is PNQ. And what rule do you think we have enough info to prove? Yeah, cover up one of your triangles, and it'll make it a little easier to see that you have two angles and the side in the middle, so ASA. Again, the abbreviation is exactly what order you see things touching in the diagram. Okay, example 6. Again, I see another one of these with a common side, but let's make sure we have everything marked as well. So WX is parallel to YZ. So again, parallel, we use same number of triangles or arrows. WX is also congruent to YZ. So I'm going to put congruent marks as well. Okay, any shared information? Shared side in the middle. So not quite enough info, but what did we do with parallel lines before? What kind of angles did we try to mark? Alternate interior angles. And looking at my two sides and knowing that I have all these abbreviations, but one of them is two sides and what in the middle? So that gives me a hint as to, well, look for those angles. And indeed, I can mark those alternate interior angles. So that means we have our congruent triangles. Our rule is actually SAS. Let's try and find the order. And again, they gave us X, Y, W. So X, Y, W. So draw your arrow in the same order in the other triangle. Again, starting at your empty angle, then going towards, second empty angle. Well, what do you think? Am I going along the parallel line or the empty line? Along the empty line, and then along the triple marked line in the middle. So Z, Y, W. Okay, we have another bisector for example 7. HK bisects angle GHJ. So GHJ is up at the top. What does bisect mean again? Yeah, cuts perfectly in half. So these two angles are equal to each other. We also know that HK is perpendicular to GJ, they told us. Perpendicular means what? That we have our sides coming together at a right angle. So we actually have right angles on this one. So right off the bat, which rule do you think we're probably going to use? Well, probably, but not all the time. If we were going to use that HL postulate or rule, we would need to have a hypotenuse and an extra leg marked. And right now I don't have anything marked. Do we have any shared sides? We do. We have that middle side is shared. But here's the thing, that's still only one side. So I don't actually have enough room to be, or enough information to do HL, but I can still do one of the other rules. Again, cover up your triangles and see what do you think you have enough information for. All right, this one is angle, side, angle. Again, draw your arrows for your order. They gave us triangle GHK. So GHK, which means what order do we need to do for the second one? Again, there's a nice symmetry to a lot of these that'll help you figure out your order, but definitely drawing those arrows in can help you keep track of everything. And it makes it really easy to name these. So that's going to be triangle JHK. Okay, a few more. It's still the same thing. We're given a diagram, we're given some info. We need to mark what we can figure out. Here we go. So, number 8. We are given that HK bisects GJ. We did the same sort of thing, but now we're bisecting GJ, which means what happens? Cuts it perfectly in half, so each half is equal. What else do we also know? We also know that we have that shared side. So we also know that HK is congruent to HK. So here's the thing. These are twisted around a little bit. They're saying we can prove that these triangles are congruent by SAS if we have what extra piece of information? Well, again, if you need to, cover up one of the triangles, and you'll see we've got 2 sides. And if we're trying to do SAS, well, which angle has to be congruent? Well, the one in the middle. So that means these middle angles in between our 2 marked sides have to be congruent. Now I can't name these with a single letter. I've got to use my triple letters on here. So I'm going to go with angle GKH and angle JKH. And again, I kind of took a hint from the names that they gave me that were already congruent. I'm still hitting that angle at K in the middle, and that just happened to be the order that they gave me for my names. Okay, number 9. We know that LM and PQ are congruent, so mark them congruent. N is the midpoint of LP, so I'm going to trace LP. That means that one gets cut perfectly in half, so mark your 2 congruent pieces. So what else do we know? It's a bow tie diagram, so I could also do angles in the middle, but that's not going to help me out too much. We also know vertical angles. Why do you think that's not going to work so much? I have 2 sides at an angle. Wait a second. I have an angle and a side and a side. That can't be good. If I was to say that out in math class, yeah, I would not be doing a very good job. If you said that out in math class, yeah, unless we're referring to a donkey, we probably shouldn't be using that word, so I don't think that's an option for here. So this is saying, well, could we prove it by SSS? Well, sure, if we had that extra side. So that's what we're going to write down here. If we know that QN, or if we knew that QN and MN were congruent, that would be enough info. Go ahead and pause 10 and 11, see if you can do those on your own, and then come back. So number 10, we're given WX is congruent to YZ. What else do we also know in the diagram? This is the same diagram as before that had parallel lines, but they never told us. So the only other thing we absolutely know is that we have that shared side in the middle. So we also know we have the shared side. So our triangles are congruent by SSS if we knew what extra piece of info. We need our extra sides. So we would need these outside pieces. And again, if you're not sure on the order, use the name of the triangle to give you your cue. So if I did WZ, let's see, that's that order from the right-hand name. So I have to go same order. I'm going to go YX. And then number 11, they told us that angle S and angle U are congruent. What else do we know? Shared side in the middle. So we also know our shared side, in other words, TR is congruent to TR. They're asking us to prove this by AAS, angle, angle, side. So what extra info would we need? We need another set of angles. Now, we could do this a couple different ways. So we could do this with our bottom angles. So if we knew that angle SRT was congruent to angle URT, that would be enough. But we could also, if you saw this the other way, we could also use these top angles. So we could do angle STR is congruent to angle UTR. Either one of those would work if we were trying to work towards the angle, angle side. Now, your practice today is just on identifying which rules to use. And then we're going to spend 2 days on using these for proof. So we're going to get a lot of practice with these rules. But definitely do ask me if you have any questions on these problems.